So after seeing the water demand and discharge per capita water demand, we'll move to the what are the various types of water demands. So this is an important one. A direct questions can be asked in the JE level exams and even in sometimes in MPSC. So among the various types, the first demand is called as domestic water demand. Domestic water demand. Then the next one is industrial water demand. After that, the next one is institutional and commercial. Institutional and commercial water demand. So the name itself suggests what is the type of the demand, or what is the, or you can say what is the characteristics of that. In this institutional and commercial, all the hospitals, colleges, church, then hotels, railway station, bus station, these things comes. Okay, so you can even write it here if you want. So write hotels, colleges, temples, etc. So these all comes under the category of institutional and commercial. Then the next is demand for public use. Demand for public use. So what is the meaning of this? You must have seen some public gardens, then public toilets are there. We call it Sulabh Sauchalay. So that all comes under this demand for public use. So Sulabh toilets we can say. Then public gardens. So this comes under demand for public use. And the next one is fire demand. So now first we'll see what is the value, what is the value of the individual demands that we have written it here. So this domestic water demand. So according to IS code, this domestic water demand is divided into two categories, that is low income group and high income group. So they have divided the domestic water demand into two categories, low income group and high income group. So just by looking we can say, or just by common sense we can say that the high income group must have higher domestic water demand or higher water demand. Now what is the value for low income group? So it is 135, and what is the unit of water demand? It is liters per capita day, that is LPCD. Now for high income group this value is 200 LPCD. Now next coming to the industrial water demand. This industrial water demand, it is given as it should be 50 LPCD. Then for institutional and commercial this is 20 LPCD. Then demand for public use, it should be 10 LPCD. So these are the values that you have to learn. You have to by heart this. There is no other way to remember it. Now among this fire demand, this value is directly not given, but for this certain formulas are given, and that formulas are called as empirical formulas. Okay, so we have to calculate the fire demand by using those formulas. And the last one is demand demand to compensate demand to compensate for loss, or we can say losses or theft. So the places where the water is very scarce, at such places there is also something which is called as water theft. That is, they stole the water or they steal the water and they use it for themselves or sell it. Okay, so that also we have to take in the total demand calculation. So what should be this value to compensate for the losses and the theft? It should be around 55 lpcd. So you can say this should be as a buffer which should be present. Okay, so if you just add this now, if you just add this, then this value should come, this value should come nearly to the total demand, should come in the range of 270 to 335 lpcd. So this is a general range I have given. So it may vary, definitely it can vary, but for designing we have to take a certain value between this. Now we will see the next one, that is what are the different formulas for calculating this fire demand. Okay, so sometimes questions are asked from here. So calculation of fire demand. So fire demand means if there is fire at certain place, then you must have seen the fire extinguishers, they go there and extinguish the fire. So whatever the amount of water is required, so that water should be present, and that water comes under this water, or we can say fire demand. So there are three to four formulas which are mainly used. Actually there are many formulas for calculation of fire demand, but these four formulas are very important and asked many times, so we'll be discussing these four only. So the first formula is Cushing's formula. So this is Cushing's formula. We'll write down the formula here. The formula is Q is equal to 3182 root P. Then the next one is Freeman's formula. Freeman's formula. This formula is Q is equal to 1136 P divided by 5 plus 10. So here Q is the discharge and P is the population in thousands. Okay. The next one is National Board of Underwriters formula. These names are very important. These formulas, if you are not able to remember, then it's okay, but these names are very important. And the last one is Booston's formula. So the fire demand is calculated by using these four formulas, and this all the four formulas are given here, where this P is population. So whatever is the population, and this population should be in thousands. That means if the population of a particular community is 5,000, then in this formula you have to substitute this as 5. Okay, it is in thousands. Now next is Q. So this Q is the fire demand. This Q is the fire demand, and this will come in liters per minute. This will come in liters per minute. So these 2 points are very important. Before this, there is no question which is asked on the calculation of this. However, this name of the formulas have been asked previously. So both thing, if it is possible, try to remember. Otherwise, the name at least you have to remember. Now this fire demand which are calculating here, this is added to the main demand which we will be calculating, and then for the combined demand we will be designing the overall system. Okay, so we have seen the various demands now: domestic, industrial, institutional, demand for public, then fire, and then for losses. Then how to calculate the fire demand, that also we have seen here. Now other than this, there are certain other values which if you are interested you can remember. So I will just give it here. So for offices, particularly for offices, you can take the value between 45 to 90 LPCD. Then for schools also 45 to 90 LPCD. For hotels, take the value as 180 LPCD, well LPCD, and it should be liters per bed. Okay, so if it is possible you directly write it 180 only, so this will be more clear. That is per bed it should be 180. So if there are 2 beds, then it will be 360 liters that is required. Then restaurants, for restaurants it is 70 liters per seat. So what is the seating capacity? If you multiply it, you will get the total demand from restaurants. Then for hospitals, it is divided into 2 categories: a hospital which is having less than 100 beds and a hospital which is having greater than 100 beds. So if it is less than 100 beds, then it is 340 liters per bed, and if it is greater than 100, then it is 450 liters per bed. And for bus station, railway station, then airports, to calculate the water demand here, you have to take the value as 70 LPCD. Okay, so now I have given you some other values. If you are interested, you can learn this. In this, if you want to calculate, let's say for this restaurant, let's say there are total 20 seats are present in a restaurant. For a restaurant, 20 seats are present. So what is the demand? So the demand is 20 multiplied by 70. This should be 700 into 2, 1400. That is 1400 liters. So 1400 liters will be required per day for the restaurant if you want to design, or if you want to take the demand into consideration. So anyways, if this value is asked, then it will be asked directly. So you can just remember the formulas for the design purposes.